Look, attackers love cloud environments. You know why? Because they're so easy to misconfigure. These misconfigurations often lead to threat actors getting unauthorized access into these cloud environments and wreaking a bunch of havoc. As a matter of fact, I recently made a video about cloud identity and access management and how several organizations get it wrong. I highly recommend checking that video out on the basics of cloud IAM and security. But in this video, we'll be doing something different. We'll be investigating malicious activities that have occurred within an AWS cloud environment. I'll teach you how to use JQ, a command line tool, to sift through Cloudtrail log data and identify specific attacker behaviors. But first, you might be familiar with the Certified Cyber Defender certification, which I made a couple of videos about recently. Well, this video is not about that certification, but the same Cyber Defenders team responsible for the CCD certification has an online cyber range packed with a ton of defensive security labs and challenges. This is Blue Yard Labs. Every defensive security domain from threat intel to detection engineering, endpoint forensics, cloud forensics, threat hunting, malware analysis, and network forensics are covered in both the free challenges and the pro labs, which come with the subscription. And today, we'll be diving into an AWS Cloud Forensics challenge from the pro labs. Alright, so since I already have a Cyber Defenders account, I'm just going to go ahead and sign in here. We're going to go into the Blue Yard Labs, and we're going to select the category of Cloud Forensics. Here we're going to do the S3 Credentials Hunt Challenge. Let's take a quick look at the details here. It says the scenario is a prominent US-based organization recently received an official notice from AWS alerting them to a potential security breach. One of their AWS access keys appears to have been compromised. Coincidentally, a subsequent internal security alert indicated that Cloudtrail login had been unexpectedly disabled. As a cybersecurity specialist, your task is to thoroughly investigate this series of events and figure out the timeline of these events. Tools, JQ. All right, cool. So we're going to go ahead and start this lab. By the way, you could get help in the Discord if you ever run into an issue or whatever happens. And you can see the first blood here. Shout out to my guy, Pet Taker. And then we can go into starting the lab. We're going to go through all these different questions here. So we're going to go ahead and start here. And we're going to open the questions by the side here so we can easily sift through this. Let's go into the readme.txt. All right, it's basically the same thing as what we had earlier on. Artifacts folder contains the artifacts to be analyzed during the lab. Perfect. AWS logs contains the AWS Cloudtrail logs, and then description, command line, utility to pass. Okay, and then any additional tips that may be helpful for completing. Okay, cool. Got that all set up. All right, let's go into the artifacts folder and go into the AWS logs. Actually, I don't like dealing with this from the UI. So what I'm going to do is I'm going to just open this folder from the terminal. Open terminal here. Perfect. Looks great. I'm gonna make this a wider screen, and then we're gonna navigate into the AWS folder. So let's just gonna list, and then we're going to AWS logs, and then if we do a tab here, we see another folder for the account ID, and then another folder for Cloudtrail, and we can see here there's like a separation for Cloudtrail digest, which we won't be going into, but it's definitely something to be aware of. Just a different way by which Cloudtrail also logs, but nothing we're gonna go into in this video. And next it goes into, actually let's choose Cloudtrail, and then it's going to go into the region. Okay, so we have multiple regions here. I think I should probably just open a new tab here because I want to know what Cloudtrail region we're going to be investigating. So let's actually do a file and then open tab and then see ls and then cd. Actually, oh, let's see. Oops, ls. Okay, so it doesn't tell us what region we're going to be analyzing this from, which is a bit concerning. All right, no problems at all. We can try to just investigate the different regions and see what exists in those regions. Maybe there's a clue from the details here. Let's see. Yeah, nothing here. Also, we go back to the README. Maybe there's some details there. Compromise the subsequent blah, 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 blah. All right, so there's no information about what region we're going to be dealing with here. So I guess we're just going to have to sift through these different regions and see what exists here. So let's look at, hey, real quick, before we get back into the video, the Cyber Defenders team was kind enough to offer a 10% discount on the Certified Cyber Defender for the very first 10 people that use the link in the description and this code on the screen. A huge thank you to the Cyber Defenders team for sponsoring this video and offering you, my subscribers, this discount. Now let's get back into the video. AP Northeast 2023. Okay, and so these are basically files that have been compressed using the gzip compression algorithm, and gz is widely used for file compression, making it easy to transfer and store different kind of files. So what I like to do is I like to bulk unzip these files. So what I typically do is I do a find and then everything within this directory, and I use a tag type F option to specify that I'm only interested in finding the regular files and not the directories within this particular folder. And then I use the exec command to to run a gunzip or g unzip against everything within this directory, and then we have to close this command. Okay, looks like I had a typo there. I always have typos. Let's replace that with find enter paths must precede expression exec. Oh, actually, there's supposed to be a oops. It's supposed to be tag exec. All right, let's run that. Boom. And if we clear it out, all right. So we can see that everything here has been unzipped. And what I'm gonna do is I'm just gonna grab this particular one, and we could just do a cat on that space selection. Whoop. Okay, and then just boom, and then we can see what has happened here. So it looks like there's some activity here. I can already see an access denied, which is good. I like indicators that something is happening here. So this is good. I like this. Bunches of user here is like a data science Annie. Okay, nice. But yeah, basically I'm just trying to orient myself about what's happening in this environment. I can see some things that might be a bit of concern, like someone trying to list functions and some things not being permitted. So that's actually perfect. Now let's go into the first question and see how we're going to answer that. So let's go to questions. So to properly track the activities done by the attacker in the environment, you would need to determine the source of the attack. What is the attacker's IP address? Now this is going to be trying to find the different actions or different IP addresses that happen within the environment. What I want to do is I want to aggregate everything I'm seeing here, right? Everything I'm seeing, because we already took a look at this, right? It's kind of hard to like sift through all these different logs. So I'm going to aggregate all of these things so I can get my answer like in sort of a list format. All right, but first, before we actually do that, now that I think about it, and I think back to the initial readme.txt, it says it's a prominent US-based organization. And in this terminal that we're in, it seems to be like this is Asian. It seems to be like this is Asian Pacific Northeast one. I'm inclined to actually go to US East one or whatever US-based Cloudtrail login exists here. So I'm actually going to take the risk of ignoring everything we've just done here and just do a cd slash that maybe, and okay, cool. And then do an ls here again, and it seems like there's a US East one and there's a US West 2. So let's actually go into the US East one. I'm just taking a hunch here, right? So let's go see what's inside here. Oops, not LSD, ls, and then let's go to 2023. All right, and then in there. All right, and do an ls. Okay, this looks like a lot more is happening in here. And let's do our gunzip command again. So I'm just gonna try to find that gunzip command. It should be somewhere up here. We lost it. All right, let's recreate that gunzip command again. We're recording. Okay, I am recording. I was so scared. All right. Trying to find that gunzip command. All right, let's try the gunzip command. And I keep calling it gunzip, and I don't think it's actually supposed to be pronounced gunzip, but let's just do g find in this directory files. If I can type F, and then it should be type F, and then let's do an exec. Come on, I can't type today. Wow. Okay, g unzip everything here, and then the last two things are basically to terminate the exec command. So let's go ahead and run that. And if we do an ls, boom, everything here, that's a lot of JSON files. All right, cool. And then let's do a cat for any of those JSON files. Wow, okay, that's a lot. So let's just do an ls again. Oops, not LSD, ls. And then let's grab one of these JSON files. Let's copy just to see what's inside it. Do a clear, and then let's do a cat for one of those things, and then do an enter. All right, looks like there's, okay, I actually do like what I see here, because I know that this scenario is based on S3 credentials hunt. I already see some bucket stuff happening here. Like I see S3 bucket, so I think this is the resource type. So that gives me some confidence into something that's happening here. So what I want to do now that I know that this is probably where I'm supposed to be in, not Asian Pacific, I actually want to start aggregating everything that's happening in this environment, right? I want to aggregate all the events, the IP address, the source IP, the event time. That's just kind of like how I like to use my JQ, so that I can see everything in a tabular format and basically just kind of look at, okay, what's happening at a high level. Because sifting through logs like this, for example, it's a bit difficult, and we can't sift through these individual logs. We have to surface some specific things from these individual logs and just use what we've surfaced from these specific things to, draw inferences on what might be happening within this environment. So what we're going to do is we're going to do some aggregation with JQ. So we're just going to do a JQ, and then I'm pretty familiar with the Cloudtrail log structure. I kind of have an idea of what it looks like, what I want to extract from it. So let's open quotes here, because we're going to have a very long query here. We're going to start by the high level records because this is where we're parsing the Cloudtrail data logs from. And if we can actually take a look at these Cloudtrail logs, like for example, this one, we can see this is the JSON array that we're trying to pick. We're going to pick some specific properties that we're going to aggregate across all of the Cloudtrail logs we have within this directory. So let's go back in here and then we start the structure of that query. This is going to be a pretty long query, but we'll get through it. So let's do JQ and then open our quotes again. And then this time we're going to do records. And that's again the high level JSON array that contains all of the different objects and properties. And then we're going to looking for some specific things. So I like to order it according to how I would look at it within like a sim. So start with the event time, and then of course we want to know the source IP addresses of the different activities happening. So source IP address, and then user identity ARN. This is just the user identity ARN. I think it contains all the details we need. Also user identity type, and then also event name. And then I like to put this in a tabular format, and then actually the query quotes in here, and then basically everything in this directory. And then I'd like to pipe that into a sort so we see it in the right order. So it looks like I'm missing something here. User identity. Okay, so I should put a period in front of that user identity. So it didn't see it as a top level. Oops, I didn't see it as a top level, I think, property in this case. So just put that period in there. Boom. All right, perfect. So not the prettiest view, but it's a really nice view of like everything in a nice, structural format and tabular format as well. And we can see a bunch of things happening in here. There is a lot going on in here, but we can easily actually see what's happening like at a higher level. And we can see the root user doing a bunch of things that is actually concerning. But I want to answer the question here of, to properly track the activities done by the attacker in the environment, you would need to determine the source of the attack. So what is the attacker's IP address? From what we know, the access keys were compromised, and subsequently an internal security alert indicating that Cloudtrail login was unexpectedly disabled also showed. So I would actually want to dig deeper into these logs here and see which one has stop login or something like that for Cloudtrail. So this is a lot to filter through, and what I'm gonna do is I'm just going to go back into that, and also I'm just gonna grep or log, whatever that brings. So looks like we have start login here, and we have create login profile. So that's interesting. It says Cloudtrail login was unexpectedly disabled. We could do a quick Google search because I'm pretty familiar with the Cloudtrail login API calls, but I might be forgetting it. But let's see, Cloudtrail disabled. Cloudtrail login disabled, and we can look for what the API call within the AWS logs is. I'm just gonna go back here and just do API call, but first I'm actually just open this in the side and then look at what this looks like. Sometimes it's nice to look at these detection rules to see what they're looking at. So this says stop login. So that's the API call. That's what I would actually want to be looking for. So let's go back in here. I'm looking for stop login. So let's go in here, and I see a start login, but I don't see a stop login. Now I also see a delete trail here, which is an indicator of defense evasion, maybe removing the Cloudtrail that might exist, but it's not the same as stop login. Now I wonder if this might be the IP address, but I'm just gonna go with my hunch and gonna try it and see if it's the IP address. I don't have much to go with here, but let's try that. Okay, so that's not the right. Real quick here, I was looking through the video and just seeing what I was doing, and I realized that I made a huge mistake, which I eventually found out later on. I copied the 98.237 IP address, not the 185.5 IP address. So that led me down a rabbit hole that I shouldn't have gone on. And also I apologize for my camera on the right side covering some of those API calls that were pretty important in this phase. But yeah, I just wanted to point that out real quick because that was a huge mistake and I just realized it. But let's get back into the video. IP address. So we do have some digging to do. And we know that the Cloudtrail login was unexpectedly disabled. And we're specifically looking for the stop login API call. All right, let's see. Let's go back in here. So it doesn't look like there's a stop login API call here. So maybe we might be in the wrong Cloudtrail logs because I don't see any stop login. Maybe I should do a more specific search. Maybe that would find it. Login, maybe? Yeah, there's only start login. I wonder what this might be. You know what? Let's do this. this, go back, go back again, do an ls, actually go back again, do an ls, and then let's do US West 2, US West 2, do an ls, 2023 in there. So we have some logs here, and let's just do our g-unzip command again. And looks like my camera is blocking that, so I'm just gonna do a clear, and then find that command again. All right, there we go. Run that command, and then we should have those Cloudtrail logs here. And then let's run that same query that we ran to aggregate everything in these Cloudtrail logs through a grep login. So there is no login API call here again. So it's not looking like US West 2 either. That is concerning. So let's do another of these. All right, so it's not US East 1. It's not US West 2. ME Central looks interesting. So let's go in there. CD ME Central, do an ls. And then run our unzip again. All right, run that and do an ls. All right, perfect. Run this command again. Run our JQ again. Nothing there. So it's not ME Central. Where is the record of this activity? All right, so it's not US East 1. It's not US West 2. It's not ME Central. Maybe EU West 1. Let's see. EU West 1. Dig deeper into that. Run our unzip command, and then run that JQ command again. Nothing. It's not an EU. Let's go into EU North 1. I doubt if it's in EU North 1 either. Let's jump into AP Northeast 1, because I already parsed through those logs, so it should be fairly easy to go through that. CD AP Northeast 1. Oops. Northeast 1. Oh, got some ways to go in there. Whoops. All right. And then run our JQ command. Nothing. Okay, this leads me to believe it's probably in US East 1. All right, let's go back into US East 1. CD fun up. Went too far. Go to US East 1. All right, and then run. This time, let's just run our high-level JQ command again and do a sort for it. Take a bit of a deeper look into this. Scroll through all the way to the top and see what we can find here. Okay, so I realized I probably put in the wrong IP address here. This was the IP address that I meant to put in there, and I think this might have led me down an unnecessary rabbit hole. Look at that. Look at that. All right, so my hypothesis was basically because I saw a delete trail. Now, this is actually technically wrong, because delete trail is not the same thing as stop login, right? So delete trail essentially is the attacker completely deletes the Cloudtrail trail that stores the trails, and stop login is you just stop the login for Cloudtrail. So those are technically two things. Maybe I might just be way in over my head here, but I'm just following what was mentioned on indicating the Cloudtrail login being unexpectedly disabled. It's completely different from deleting a trail. But let's get back into our investigation. So my hunch here was just basically seeing a delete trail, which is basically something you don't see typically, as well as the fact that this is a pseudo DevOps user. Attackers typically like to use like some kind of weird similar names to blend in within the environment so that it's harder to identify their activities. But now that we know that this is our culprit, we can then narrow down our queries so that it's a lot more efficient. Let's do that. Now, for a second there, I realized that I was a bit short-sighted with my approach to this challenge. So I decided to redefine my strategy. So what if instead of looking into singular and individual directories, I actually look at all of the activity from a high level at all of the different regions that Cloudtrail was logging, because evidently there was a lot of Cloudtrail activity across all the different regions. So what I did was, with a little help from ChatGPT, refine my query to parse through all of the different regions and surface up what I really want to look at, which is everything occurring from this particular IP address right here. And what this command does is basically a bit similar to our initial command, just a little bit more refined and a little bit more robust for what we're looking to do here, which is looking through all of the different regions and then finding all the files with JSON in them, and then basically putting that output and then using JQ to pass through everything and surfacing all these different properties within the JSON files, of course in tabular format. And then we can add some more stuff to it, like looking for all the activities coming from this particular IP address we observed from the very first question. So let's go ahead and run that command right here. Perfect. So now we can see that we're actually seeing some things coming from ME Central 1, which I believe the ME Central 1 is the United Arab Emirates region, if I'm not mistaken. We can do a quick search for that. ME Central 1. If I can paste that here, oops, ME Central 1, and that looks like the Middle East, which is UAE. So perfect. Now we can go back into this questions and then look at it with a different approach. The question is asking here, a timeline for the incident will help identify the gaps in your investigation. When did the attacker interact with the server for the very first time? And we can see a list objects API call. Now, S3 buckets are technically servers, but I still prefer to refer to them as buckets. Now let's try to see if this is actually the time we're looking at here. And I think I would actually want to sort that. Okay, it's sorted out. So let's grab this time and see if we're approaching this the right way. Close this up and look at the typo there. All right, perfect. So it looks like we have the right answer here. So we're basically looking at the very first time this particular IP address interacted with the S3 bucket here, and they did a list objects API call, which is basically just looking for everything that exists within the bucket. Now, it looks like the next question is asking us to ensure that the environment is safe after the recent breach. Identifying the attacker's entry point is essential. What is the exact file path from which the attacker retrieved the compromised user access key? Now let's see here. So we've seen list objects, list objects, list objects. We see get object. This is the very first get object. What else do we have down here? So I'm pretty sure within one of these get object API calls, there is some access key in there. Now we have to find a way to look through all these get object API calls to find where the attacker actually stole that access key from, right? So let's refine this query to look specifically within those list objects API call and see if there's anything that contains the access key. Just gonna go ahead and clear out a bunch of stuff here that we don't need all the way to records. So we're gonna keep records, but this time we're going to pipe into, I'm going to pipe that into a new JQ search for a select. And this is just basically going to surface up the specific details within the JSON file. And we're going to see that here. So we're looking for all the list objects. Actually, no, we're looking for the event name that is list objects. Gotta correct that typo. List objects right here. And then I think I could just close this out. And I think there is there? And then add this up here. And then what I'm gonna do is take out this table format. I actually don't need that sort anymore, as a matter of fact. So I'm gonna take out the sort. And what we're gonna do here is actually we want to look for this particular IP address. So we're looking for when the event name is list objects and also when the source IP address is this IP address. Throw that in there. And I actually realized that this is not looking good at the bottom. So let me just clear that up and then finish up the query up here. Should be looking better. All right, close that and all right, perfect. So let's look in there and see what we have in these different list objects. So see a shared docs repository bucket name, and then it's looking at the list objects API call for here is looking into this bucket, this object. So shared docs repository within this bucket S3 object. It just seems like maybe there's nothing in here, or it's just listing that bucket. And then if we scroll further, same thing, shared docs repository, and this is anonymous. This is an anonymous list objects, which means that that object allowed anonymous access to it. So basically you don't need an AWS account to retrieve the data from it. So you can anyone could retrieve data from it, or list objects within it, obviously. So more shared docs repository. Okay, let's refine this and let's look into the get objects, because it does look like when we did that initial query, there were a bunch of get objects. So that was probably where they retrieved the access key from. Oh, actually it should be get object, not get objects. And again, let me just do this from the top here, and there should be get object. All right, cool. So we have a ton of get object here. All right, so there's a proposal.txt here, more proposal.txt here, report.txt, report. I wonder if we could grep for like key or something, make this a lot more refined. Clear that. And then maybe add a grep for a key. Oh well, that's actually good. So we see a bunch of, well, this key is basically the key that shows like the object that was retrieved from the particular bucket. So we can see the different objects here, which is kind of good. Was not the intended result, but still helpful. We're looking for the exact file path. So a bunch of things are txt files here. Let's see, agenda, financial, bunch of stuff here. It's kind of hard to sift through, but looks like we found something. We see a DevOps Kate access keys. Perfect. That seems to be what we're looking for. So what I'm gonna do is I'm gonna actually just refine this query here. Just do DevOps. Perfect. And this is the ARN that we're looking for. Now it looks like it's looking for the file path. All right, so we should grab this file path here. And if we grab that and copy, boom, boom. All right, looks like it was stolen from the shared docs repository. Now to think about it, if we go back up and we look at, well, I can't go back up, but if we remember when there was like a list object earlier on in the investigation, you will see that there was like specifically things within the shared docs repository that the attacker was listing from the list objects API call. And it does make sense now that they're getting those access keys, or the access key that is stole, from this particular repository. So really cool stuff there. Let's go to the next question. In a cloud environment, determining the user context can help access the potential extent of damage based on the permissions and resources accessible to that user. What is the type of user who disabled Cloudtrail? So we're looking for the type of user to disable Cloudtrail. Now, I think since we refined our approach, we could possibly get better details as to the Cloudtrail disable login, right? Because I was initially biased with my initial query when I was looking for the IP address. So let's look at disable login. I believe is the API call. Disable login. Oops, should add a quote after that. Okay, did I get that wrong? Oh, stop login. That is my fault. So again, I'm gonna just put this back up here and then turn that to stop login. There's so many API calls sometimes it's hard to remember with them. But all right, we don't have a stop login API call. Okay, so disabled Cloudtrail. I wonder what they're looking for here. Well, let's go back to that query we had initially, just aggregating all those events at a high level here. Let's do, oh, actually not that query. Not that one. It wasn't that one. All right, that one. Okay, cool. Now, I'm pretty sure this is an IAM user. It is not an IAM user. Okay. It either has to be an IAM user or an assumed role. I am going to make another educated guess. Oops. Okay. Now, it is an assumed role. And the reason why I guessed was because I already saw this assumed role here after this particular user assumed role. And probably not the best way, but some things are just a little bit intuitive when you look at certain things within the logs. I can kind of like tell, okay, this is what had happened, because you can obviously see like afterwards, like they assumed a role. So probably like compromise like, you know, different roles so that they could gain more privileges. So probably not the best approach to answering this question, but it would either have to be an IAM user or an assumed role, maybe a federated user. But in this case, it's an assumed role. Now, it still seems like it's pointing back to the delete trail, which is the only sort of indicator of a stopped login. But again, a delete trail is not the same thing as a stop login. This is more of a way by which you completely delete the trail and not disable Cloudtrail. So those are two different things, but let's move on to the next question. So from the previous question, you determine the attacker's access type. Now you need to figure out what resources the attacker has access to. What is the name of the role the attacker takes advantage of to escalate his privileges in the environment? Now this is again why I like to aggregate like this, because it just puts a lot in perspective. This is the role that the attacker used here is the assumed role. This particular assumed role, sudo devops sudo session. So let's copy that. Well, they're asking for the name of the role. Well, it does seem like the name of the role is sudo devops, and we can just copy that. That should be it. All right, that is the role. And again, this points back to what I said about like aggregating like this. It just makes it easier to kind of like identify things quickly. Of course, in a real world investigation, you probably have this in your sim where you could like dig into these things like faster. But in a case like this, like just having it a lot, you know, better aggregated like this could easily help you identify high level details. Now, to the next question. In AWS, to enhance security, users are granted temporary access to specific resources when they assume a role. This action results in the creation of a session characterized by a unique name and credentials. To trace the attacker's attacker's TTPs, can you identify the name of the session they initiated? Again, we can easily find this here. Now, this is the most efficient way to identify, but this might not immediately be intuitive if you're not familiar with AWS. But just because I typically understand like what these things look like, it's easier for me to kind of identify them within these details. So again, points back to aggregating like this and then digging deeper if you need to. And we can immediately see like the session here is the pseudo session. It just gives you a lot more access to data faster, and you can then use that data to pivot into more details. So pseudo session. Next question is, to effectively mitigate risks, it is crucial to determine whether the attacker attempted to establish persistence for ongoing access. Can you identify the name of the user the attacker created to maintain a foothold on the machine? Now, I don't really like the way these questions are actually turned, because it seems like it's on the machine. It's more so on a cloud environment, like using terms like server instead of bucket, and terms like a machine. I don't think it's probably worded. Either ways, it looks like, there was an access key created, according to the question, name of the user the attacker created. So they created a user, not an access key. So we see the create user API call. We can dig into the API call to find the user that was created. So I'm just going to pick back one of my previous queries and just update that to create user, and looks like the username that the user created was root admin Adam. So let's see if we're looking at this correctly. Yeah, that's the user. So they created the root admin Adam. Now this is also another sort of like similar naming conventions the attackers use within AWS to kind of blend in. So you see like root admin, like it's easy to kind of like maybe think this might be a legitimate user, but like it's just a way by which they like use common naming conventions to blend in to the cloud environment. So that's the user that the attacker created. So this is basically a miss of persistence. And then next, the attacker leveraged several techniques to access the account they created. What is the event name associated with their initial method? So now when the attacker creates a user within AWS, for example, as you see here, they can't immediately access that user. They have to either create another access key to access that user programmatically, or create a login profile which will allow them access that user account through the AWS console. So in this case, it seems like they did something different. So let's look at our aggregated information again. So they did a create access key, create a user, and then create an access key for that user. That's the API call that they use. So when you create an access key, basically allows you to programmatically access that user. Just basically the same thing that happened to DevOps Kate, where they were able to gain the access key for her account from a compromised S3 bucket. So back to the question here, the event name would be the create access key. So let's just put that in there. Create access key. Oops, am I missing something? My name associated with their initial method. Oh, actually, I missed that. So after they create user, they created a login profile. And what the creating login profile does, it creates like username and password for the user that they can actually use to log into the user's account using the AWS console. And after that, then they did a create access key API call, which creates the access key for the user. So this API call basically creates the login profile, which is a username and password. This one creates API keys, which you can use to programmatically access the user using AWS CLI. So I jumped the gun here. So let me just redeem myself by putting in the right answer here. There we go. And what is the name of the group the attacker added the newly created user to? So looks like they added the user to a group. So let's dig into that API call by selecting it and then just do add user to group. Yeah, so looks like the group name is administrators, as you can see right here. So let's pop back in here and just do administrators. Perfect. And last question here is, sophisticated threat actors often attempt to conceal their TTPs. Can you provide the exact time Cloudtrail login was disabled? Now, I think, like I said, this wording is a bit misleading because Cloudtrail login disabled is not the same thing as delete trail. And I'll go over that quickly. So delete trail here deletes a trail, essentially. Basically, it deletes the exact trail of a particular activity. Now, that is completely different from stop login. So stop login here suspends the recording of AWS API calls and log file delivery for the specified trail. That is what it means to stop Cloudtrail login or disable Cloudtrail login. That is totally different from deleting a trail. But just for the sake of this lab, we'll go ahead and go by the answer of delete trail. But for the real world, those are two different things. So the exact time the Cloudtrail login was disabled, this was here. Let's just copy that and clear that out. Oops, so I'm missing something there. All right, cool. Now, this has been a really cool learning experience. We looked at different ways by which attackers are able to compromise database environments. And honestly, I spent maybe way too much time with this lab than I should have. But just because I really enjoy digging deeper into the data and seeing what exists there beyond it, and also just explaining things in detail so you can understand like the why behind the actual attack beyond just a response. Because you can easily get lost in the sauce of, oh, let me find that flag. Let me find that flag. However, understanding like the mindset of the attacker and what they're doing, and also understand the resources and why the attacker is leveraging those vulnerabilities or those misconfigurations against the resources the way they do is important if you're responding or doing forensics in the cloud environment. But thank you for watching this video. I'll be doing more cool videos like this in the future. Definitely be sure to check out the Cyber Defenders Blue Yard Labs. And thank you so much to Cyber Defenders for sponsoring this video. Thank you to you for watching this video, and I'll see you in the next video. Bye-bye.